Good morning. How was the sound? Good morning. All right, it looks good. I just tested that. All right, so it's only a few of us here. Should I wait a bit? Yeah, I've turned off all the other noises in the room. And you just hear my voice. So I'm not sure where everybody is, but I guess they probably thought I'd start a little later. I'll give them a minute or so. Did you get a chance to look at the question paper? Hi, Melanie, Daviana. The questions that I shared. Yeah, cap locks. It's okay. It's like offensive when you use cap locks, right? You have to apologize. So let's recap what we've done so far. Looking at the formula sheet, we've discussed most of it. We've talked about the time value of money basic formula. We talked about mixed cash flows and the NPV formula. We've talked about perpetuities and perpetuity with growth, and we've talked about annuity. So that just leaves the last formula. So I also encourage you to add the extra formulas like annuity due formula and the two different formulas associated with annuity due. And what else was another one? I guess you could add the bond formulas, but the bond formulas they're just a combination, right, of annuity and basic time value of money. Annuity for the coupon payments and the basic time value of money for the face value of the bond at the at maturity. So those you can add onto the formula sheet. So let's see where we left off here. And I asked you to finish reviewing the notes and begin exercises. Okay, so I'm going to complete the notes and then we'll talk about some of the exercises together. And then I'm going to send you some more material after a brief break. So we just did this one. Oh no, this is where we left off. Okay, so for this one, a 3% coupon bond pays $1,000 in 5 years. So that cannot be changed. But because it's selling, it's trading between investors. The bond sells for $854.55 currently. So implicit in that, knowing this, what should the yield be? What would be the yield to maturity on the bond? And because I've done this annually, I want the yield to maturity to be the effective annual rate. Anyway, maybe I'm saying more. I'll explain the difference between effective and not effective shortly. But we can do this is the point. We have all the tools to solve this. The coupon rate is 3%, which tells us that 3% of $1,000 is $30. So this is the timeline for this investment, $30. So if you buy the bond for $854.55, that's why it's a negative, you will get these coupons, and then at the end you'll also get the face value of the bond. So the coupon rate you're told is 3%, so that's $30. But the price is less than 1,000, so that is a discount bond, and it means, as we learned last class, that the coupon rate is less than the full interest, and you get a discount as a result. So it should be the case that the coupon rate is less than the interest rate. So the interest rate should be greater than 3%. So let's see. That's just giving you an idea of what to expect, but we can solve this. We should first write the formula. So this is what I expect you to write in a test situation. Don't forget the two parts. This is the annuity part, and then this is the lump sum $1,000 at the end when the bond matures. And so these are the keys you punch into your calculator, which you do not put on your test, but if you want to write it on your test paper, that's fine. It just won't get any grades, give you any credit. So this is the thing, this is the thing about coupon bonds. We get to enter values into every key. We want to find interest. The thing you have to be careful about to get the right answer is that one of face value and present value has to be negative. So the way we tell this story is that we purchased the bond for $854.55, so that's a negative cash flow, and then we will get the payments of $30 every year plus the $1,000 at the end of the 5 years. So this one will be negative, the present value will be negative, and the future value will be positive. If you enter them correctly, you will get an answer. What do you get? You should get 6.5%. So you need to keep in mind your calculator will give you the answer in percentage. Let's put that there. Questions? No, you don't have to solve it, Kevin. All you just have to put like this. If I ask you, so notice, if I asked you to isolate I, can you do it? If I asked you for the analytical solution, like isolate I, could you do it? That's right, Kevin. You can't do it as easily as we've done it before, not for bonds, okay? and not for NPV either. And when you have like the long expression with all these in the denominator, it's very, you're not going to be able to isolate I by itself. You will be able to, you could iterate or you could approximate an answer, but otherwise it's not easy. It's not straightforward. You're not fully going to isolate it. Any other questions? The issue is going to be that there's an I here, and then there's this term here, and you can't combine them. You can't isolate I by itself. You're going to have to try and do some kind of guesswork approximation to get the answer for I. Okay, so that's why we love our finance calculator that's programmed to do this. And it does all of that estimation itself. So this is a big reason to have the finance calculator. So here you feel the reward of learning how to use it. What about another variable? What about the coupon rate? Oh, let me go back here. So notice as I promised, I should be greater than 3%, and it was. It was almost double. It's double. 6.5%. All right, let's do this one. So again, this is a sale of a bond that's been valued at $900. So the thing is that bond prices are obtained in the bond market. Okay, so based on bonds of comparable risk, you're told that this bond's yield to maturity is 8%. It sells for $900. What would be the coupon rate of this coupon bond? Well, it's a discount bond. You're told the yield should be 8%. So now I is so the coupon rate should be less than I because it's a discount bond, right? So bond holders are compensated with a reduced, like a price that's less than 1,000, since the coupon rate doesn't fully pay the interest. It's paid with the face value. So this must be a discount bond. And right now you're told that I is 8%. So C must be less than that. Now, I'm just giving you a rough idea. If this was like a multiple choice question for you and all the options, among the options, there was only one that was less than 8, you could answer this without actually having to solve it in your calculator, okay? But in this case, I want you to get the exact coupon rate. So how do we do it? We set up the equation. All right, so we have the coupon piece with the payment here. You could also use C1. And then the face value there. And it's the same thing. I mean, it's a different, this one you could actually isolate for payment. But anyway, we're going to use our calculator. We put 5 into N, 8 into the yield to maturity or the interest rate, minus 900 into present value, and 1,000 into future value with a positive because that's to be received. And then you ask to compute the payment. So you get this amount. You're not finished yet. That just gives you the payment. Where does the payment come from? The payment comes from a calculation of C times FV. So we know FV, we know the payment, so we can solve for C. This is the rate here. So you need to remember you just have to take that extra step to find the percentage. You have to take the amount and divide by 1,000, as opposed to if you did it to find the payment, you would multiply by 1,000. To find the rate, you have to divide by 1,000. So in here, you have to remember what a coupon rate is and how to use it. Does everybody get that answer? Should I continue? Some of you have already done these. Okay, so we're on to the final formula on the formula sheet. Right, looking for C. Very good. You could also put this on your formula sheet, this to remind yourself. So yeah, putting everything on one page is nice. So you might want to add those to your formula sheet, this and then also the bond formula. All right, let's move on. So the last formula on the formula sheet is the annuity with growth formula. How many of you seen this before? Annuity with growth. Who's seen this before? Okay, Daviana, where did you see it? In 3106? Okay, wow. All right, so this formula, it's always debate about teaching that in 3106, but I always teach it. I think it's important. Okay, so let's see. What is this formula? Here's the timeline for the formula, and you see it looks like the timeline for perpetuity with growth, except that it stops. All right, so that it's only T payments. The payments are related by a growth factor, otherwise they are different, but they are related by a growth factor of G. So we need to start with our perpetuity formula and then carry out the same steps that we did for the regular perpetuity formula. So you take the perpetuity with growth formula, remove all the cash flows after this point, which really is a perpetuity, by subtracting the present value of those cash flows off. So that's what we're going to do to derive this formula. Here's an example of why we want to do this. So Angel or Angel can purchase an annuity to receive 30 years of supplemental pensions beginning next month. These payments will be indexed for inflation. So that's really important. What's inflation? Inflation is the rising price of commodities or things you purchase. I should just say consumer goods, right? So that's the price going up by 0.2% per month. The prevailing interest rate is 0.5% per month. So let's distinguish these percentages here. What's what? So this is the growth rate of prices, which means that consumers on a fixed income like a pension should have more money so they can buy the same amount of things. So they need more money in their bank accounts to be deposited if they're on a pension. So they need these payments that they get should be indexed or adjusted for inflation. However, in interest rate, the prevailing interest rate is 0.5%, and that is to take account of the fact that there are financial markets available to the consumers, and this is the interest rate that applies to them. So these guys are going to receive an extra 0.2%, which is 0.002, a factor of 1.002 times $100 in the first growth period. So we have to wait one period to get the 100, then the next one grows, and then the next one grows. So these are growth factors. So it looks like interest, but you have to distinguish between them. Interest goes in the denominator, right? Because we have to look at the time value of money when we calculate the present value of this. But this growth goes in the numerator in the top, because our amounts are growing to adjust for inflation. So here I derive the formula that you just saw for people who've never seen it before. And you can take time and sit down and look at this. It's really important that you understand this trick. I don't know, call it a trick, but it's this method of deriving the formula. I'm not going to ask you to derive it, but like I mentioned before, these techniques are important for you to learn because you might have to do this yourself when the formulas don't apply perfectly to the application, some problem you're trying to solve. So this is the growing annuity for these set of cash flows, but we aren't going to get all of those. We'll stop here, right, up till T. So what we have to do is remove all these future cash flows. We do that by writing the growing perpetuity formula, but at time T. So that's in the future. We know that future dollars are worth less today, so I need to discount that by T periods. And then take these and subtract these later cash flows. So I'm going to take present value of A minus present value of B, both times 0. And that will give me the formula. So those two subtracted, this amount subtract this, and then I pull this out as a factor. That's, here and here. That leaves a 1 here for this, and then all of this over here. So that's where it comes from. So the I is always in the denominator, and the G is in the numerator, except for this part, because this is the growing perpetuity formula that I discussed with you, that the growth rate is offsetting the effect of the erosion of dollars over time as a result of the interest rate. So this is the formula, and it does have a limitation. It only works when I is not equal to G. It doesn't mean that I cannot be equal to G. I can be equal to G, and you can get an answer for this, but this formula will not apply. So let's write down the conditions for this to work. Let's pull, because I did this for the other ones, let's do it for this one. What are the conditions for this formula to work? I have to go back and pick this out. It's been a while since we talked about this. So remember, okay, let's take this one. Or maybe I should just take the perpetuity. Okay, so remember we talked about these conditions, so make sure you review those. I'll take this one. So these are the conditions for the annuity. Okay, so what are the conditions here? Okay, so the cash flows grow at a constant rate. I'm doing it like this so you see that all these formulas are related. So cash flows grow at a constant rate. Cash flows are finite. The first cash flow occurs one period from today. The only thing I have to add is G. Okay, so cash flows grow at a constant rate, G. Cash flows are finite. First cash flow occurs one period from today. And the interest rate never changes. Okay. All right, so I actually probably should have put it here. Let me put it here too, to repeat. It's very important in, well, any discipline, but particularly in economics and finance, to know your assumptions or your conditions. So this formula only applies, because I should add this extra part. That's true. So cash flows are constant. No, that's not right, right? The cash flows grow at a constant rate. Cash flows grow at a constant rate, G. Cash flows are finite. First cash flow occurs one period from today, and then the growth kicks in, so let's add that. Our growth starts in the second period. And the last thing to say, you could only use this formula if I is not equal to G. If I equals G, you have to use another technique and you have to have another formula. So let me just add I not equal to G to use this formula. What happens if I equals G? If I equals G, this would be a 0, and this would be a 1, so you would end up with 0 on the bottom and 0 on the top, because it would be 1 minus 1, which would be 0. And that's known as indeterminate, and that cannot exist. So I cannot be equal to G to use this formula. All right, so let's apply this formula, and I'm going to show you how to punch this into your calculator, because there is no function otherwise to plug this in. Okay, so let's do this together. Here I've put all the numbers in carefully, and I have to punch this in my calculator. So what I'm going to do is simplify this to begin with. So this is 0.003. And where I'm going to start is here. I'm going to start entering here. Now this is why I really want you to use the TI BA2 Plus, because you have to practice how to enter this if you really want to write those professional exams. You have to practice how to enter it on that calculator, because that's the only one you can use. So let me expand this a bit and tell you what to type. So we're going to start here. So we begin with 1.002 divided by 1.005, and then say equals, and then you want to raise it to the power 360. Then you want to change the sign and add that to 1. Then you want to multiply by 100, and you want to divide by 0.003, and you should get your answer. So try that. So there's no other way to do this but punching it into your calculator. You should get the answer. Let me know if you got it. 21,970 and 77 cents. Uh-oh, Daviana, that's too high. That's right, Angel. No, you can't. You have to actually punch it in. You have to actually calculate it. So try again, Daviana. I don't know what's happening there. 1.002 divide 1.005. This is a 1 maybe. 1.005 equals power 360. Change it to a negative. Add 1. Oh, maybe that's my problem. Let's put an equals. We have to put an equals here. Let's try that. Then multiply by 100, divide by 0.003. Try that. And then you have to say equals. So Daviana, did you set up your calculator with P by YI? Make sure you did this setting. I don't know if that's going to change it, but maybe make sure your calculator is not in begin mode. That would make it bigger. Make sure BGN is off. Do you see BGN on your screen? Well, the only other thing. Let me do it so you can maybe follow along. Let's do it together. Hold on. All right, I'm going to do this together with you. And prove to myself it's the right answer. Okay, so let's see. Clear that. I'm going to hit 1.002 divided by 1.005 equals Let me adjust this just for the picture. Okay, and then power 360 equals, change to a negative, +1 equals, multiply 100 equals, divided by 0.003 equals. Maybe you didn't use brackets, or I don't know. I get that answer. Gotta keep trying, okay? Keep practicing. Which part? The bottom? No. At the end, you don't have to use brackets. Here, just use this number, 0.003, not this. If you do this, you have to put brackets. So I did 1.002 divide 1.005 equals y to the x 360, change the sign, add 1 equals, multiply 100, divide by 0.003 equals. Yeah, that's how it should work. You don't need the brackets. Practice, try again. Now, the only other thing I can tell you is if you have a wrong setting. Actually, tell me which calculator you're using, or app. Are you using an app? Sometimes those apps have different settings that you have to fix or set or make. Thank you, Angel. I'm glad you got it. It takes a little practice. Don't be discouraged if you're not getting the answer. You have to practice at the beginning. Okay, the negative sign. Yeah, don't forget this. That puts the negative here, so then you can add 1. It's backwards, but it avoids having to use brackets. Oh, you have to put equal here? Let's put equal. Put another equals here. I don't think I did, but anyway, you can be safe with an equals. Ah, da Vienna. It should be the same. Let me see. I'm gonna try it. I have that too. Let's see. I have the HP 10B2 here. There it is. All right, clear. And it shows here that it's an N mode, and I have P by Y. Let's see how it looks from your view. I'm gonna fit it on the screen better. All right, so let's try this. 1.02 divide 1.005 equals to the power. Okay, you have to use a red y to the x, or it doesn't work. That could be your problem. 360 equals, change the sign, which is, where's the sign change? Is it just this one? No, that's not it. Oh, here it is. Okay. Change the sign, +1 equals multiply 100, divide by 0.003 equals. Okay, so it worked. So the problem might have been the y to the x key. You have to hit the orange key first before you do that. Okay? Anybody else? Okay, the extra equal. So Daviana, you got it now? Okay. Okay, very good. Okay, so that's it. And yeah, very good. So let's continue. So we did it once. You guys can watch this video to remember what we did. All right, and we got the answer, and that's it. So what if I does equal G? What do you do then? So I'll give you an example and we'll sort out what to do. So if the formulas don't apply, you have to make, and you don't have a way to adjust the formulas so that they apply to your problem, you have to go back to the timeline, first principles, and using the basic time value of money formula. And I'll explain how you do that. So here's the problem. You are considering a deal where you will receive $100 cash flows for 4 months starting next month, and each month thereafter the cash flows will grow by 1%. So here's the timeline. What would you be willing to pay for such a deal if the effective monthly interest rate is 1%? And so what we have is a situation. Growth is 1%, but also interest is 1%. So I is equal to G. So we cannot use the formula, does not apply. But we can just derive our own. So here is the timeline. You'll see that a pattern will emerge by doing this. The first amount, 100, discounted one period, is 100 divided by 1.01. The next amount will be discounted 2 periods, and it would be 100 divided by 1.01. Sorry, not 100, but 101.01 growth factor. And this would be 2 periods of discounting. So I can simplify that because 2 of these cancels with one of those, or one of those cancels with, one of the 2 cancels with one of those. And what does it give you? And then this one, there'll be 2 growth periods and then discounted for 3 periods. So 3 of these cancel with 2 of those. Sorry, 2 of the 3 cancel with 2 of those, and it leaves you the same number again. So there's an offset that continues between the growth factor and the erosion factor. And the final term oops, 3 of these cancel with 3 of those, leaving just 1. I need to dust my fan. I think it's giving me allergy. Not exactly allergy, but it's making me sneeze. So you see, you have the same result. So you found a pattern. The growth is canceling with the erosion factor of interest. So all you have in the end is that the present value of this problem is going to be 100 discounted 1 period, because the first cash flow is 1 period from today, and you multiply it by how many payments there are. In general, we can write, this is another formula that you can put on your formula sheet. When I equals G, and the first cash flow is 1 period from today, you could use this formula for C1, 1 plus I times T. So we just made it up. Thank you, Miguel. Okay, so you can put that on your formula sheet. This is just reiterating what I said. And here's our result, our answer. So I refer to all these formula as simplifications to remind you that these are simplifications given certain assumptions or certain characteristics of the timeline, okay? Don't forget those. That's right, Angel, you have to add them all. So the formula doesn't apply because I was equal to G, but the cash flows do add up because they're finite. We just add them up. And we can add them because they're all at time 0. You guys got it? $396.04. Exactly. Okay, so that's done. All right, so we've talked about the annuity formula, but you understand that there also exist annuities as products, right? Individuals can take, set aside money into an annuity product by a financial institution, offered by a financial institution, and then they can withdraw from that annuity, and a pension would be that case. So I'm going to use the annuity to talk about pensions now. So this is another application. So we've done quite a wide array of applications. If you've purchased your textbook, the digital textbook, you can start reading the chapters and getting more background on the different kinds of products and financial instruments that are available. And I'm going to focus on the mathematic part because students seem to really appreciate that. But I hope you'll do the background reading, okay? Because that's what the textbook reference is for. So here we have a pension problem. And we're going to use several of the formulas, and we're going to use them in a different way that I haven't done till now. I'm going to talk not just about present value of annuity, I'm going to talk about future value of an annuity. All right, now that's not hard to do on your calculator. It's a matter of pressing a different button, the future value button. But you have to denote it. You have to also know how to put that in your formulas, or adjust your formulas. So here's the story. We're going to pay $3,000 per year for 30 years into a fund that earns 12% per year. Now, this is a really high rate. But if you think about the stock market, and you think about, and we'll talk about this when we get to talking about risk and return. The stock market on average over the last 80 years, on average, because the stock market has been up and it has been down. In terms of return per year on an annual basis, on average, its return is about 11%. So I put 12 here. So if you're able to earn a return on average over time of about 12%, this would be meaningful. However, as risky as investing in the markets are, over a long term, a long period of time, the average return is quite substantial. You could never get this in a savings account, with a bank. Not even right now. Like, they're less than 1%, less than 0.5% savings rates. So I'm going to use that as though this is realistic. And the first payment would be in 1 year, and you'll save for 30, and then you begin withdrawing from the fund. You will withdraw for 20 annual payments starting 1 year thereafter. So what we have really are two annuities. This annuity here, and it fits the formula because the first payment is 1 period from today for 30 payments. And then we have a second annuity that starts here. The first one is a withdrawal 1 period from today, and it goes for 20 years. So I've drawn it out here, and I want to figure out this number using two annuities to get my answer. Are you with me? You understand what we're doing? Now, I've written this here to remind you that at every tick mark, at every point in time, you can see it as the present value of future payments. You can also see this as the future value of past deposits. So I've written it like this. Now we have to know how to apply this. But are you guys comfortable with this? So this number is both the future value of these 30, and it should match the present value of the future withdrawals. They should match. So this is the linchpin in this problem. This is the key that's going to get us the answer. So we begin with this annuity here, but I want the value of the annuity in the future. I don't want the present value of the annuity. So that means the cash flows in will look like this annuity here, $3,000 at 12% for 30 years. That's the present value of it. But I want that in its future value form, which is really, this is a lump sum now. So this would be here. Can you see that? So that would be the present value here, but I want its future value equivalent. So since it's a lump sum, I can translate that into future value by accumulation. That's what this does. So these two formula, you can put them together, or you can just put this whole thing in here and write it as a big long formula. That's up to you, but you need to, in the test situation, show me that you understand that this present value needs to be adjusted to the future to put me here. So this would be the fund that I have up here. It's quite a bit of money. So this amount accumulates to this amount at time 30. Almost $1 million, $750,000. And they relate because I accumulate that for 30 periods to get this, okay? Now on your calculator, so you'd have to write these two steps, or at least put this amount here and write the whole thing as FV30 equals 1.1230, and then the annuity part. I don't like to think that it's a different formula. Some teachers teach it as a different formula. I don't like to do that. It's just it's the future value version of the annuity formula. And this is really easy to get on your calculator. Let's do that. Let's enter into our calculator 30 and then 12 as the interest rate. Love it, such a high number, 12%. And then we don't want the present value, right? So let's put 0 into PV, and then we tell it that is $3,000 payments. And now we ask to compute FV. So we didn't do this before, but it's an important skill, or it's an important key. So that should give you this answer here. If you want the PV, instead you would put a 0 in FV and ask for PV, but we want the FV, future value. So $3,000 for 30 years, it's $750,000 at 12%. If you guys can start saving in that way, you could hope for this amount. You'd have to believe that stock markets will continue to rise on average 12%. And I can't promise you that, but that's what you would have to think to believe you would make this amount by the time you retire. Start early. That's the best advice I can give you. The best thing you have going for you, the advantage you have above older people like me, is that you have time. So don't squander time, don't waste time. But I'm not giving you financial advice here. I'm just saying to look into it. $3,000 might be a lot of money for you. $3,000, if you save $3,000 a month, not $3,000 a month, sorry. If you took $3,000 and divided by 12, that's the equivalent of $250 a month. If you guys could do that, and start saving, and you could find a way to get that kind of return. It's a lot of money. And it's estimated that to retire, you need about $1 million to retire comfortably. Anyway, there's lots of things to talk about here. But let's stick with the problem for now. So with that, you'll see with almost $1 million, you can retire quite comfortably. You'll leave that amount to accumulate 12%. You leave it there, but you're withdrawing, so it's a sinking fund. You're withdrawing a little bit every year. So how much can you withdraw? That's the second question. So what I've done here is I'm going to store, well, I put negative 3,000 as the payment. That'll be better so that this is a positive. But if you have a negative future value, just change the sign and store it. So store in 1, because I want to use it for the second part. The second part is another annuity where the present value of that fund at 30 years is this $750,000, and I want to figure out the payment. So you need to write this out as well, and then enter these. So now it's 20 years at 12%. You want to store into present value the amount that you got from future value, and you want to do that with all the decimal places, okay? That's why we use storage and recall. Put future value as 0 so you can ask for the payment, and see, you make about $100,000 a year in retirement as a result. So these are quite reasonable numbers, and the reason why you're advised to save about $1 million in today's dollars. Okay, work on that. I'm going to take just a little break, okay? Let me know when you've got it. All right, I'm back. Questions? Were you able to get the answer? Did you follow all the steps I put there? So let's see. In the first step, I want the future value of 30 payments at 12%. I want the future value, so I'll put 0 in present value, $3,000 or payment, so I'll put a negative, and then I'll compute the future value. So now that's going to go into store 1. So that's stored. Now I start over, and I now do the second part where I withdraw. I withdraw 20 at a rate of 12%. So it continues, the fund continues to accumulate 12% at 12% for everything I've left there, but I am making withdrawals. So when will I drain my fund? Sorry, no, that's not 3,000. So now I want the present value is recall that $750,000 pension fund that I put into PV, and then I put 0 in FE and ask to compute what payment I can receive. So that comes out as a negative because I can receive that. If you enter in the PV as a, so if I recall 1 and put that in as a negative, as though I have had to deposit all of that into a fund, so we'll make that a negative, and then I compute the payment, it'll give me positive. So anyway, working with the positive and negative, just got to be clear that one of payment and PV needs to be a negative, but not both. So I guess I could add here a negative sign. So it should be what you could do to get exactly this. If you want to get this as a positive, you would have to do recall 1 and then change it to a plus or minus, like change the sign. I guess I'm missing that step. So you make it a negative, and then it'll give you a payment of positive. I mean, it's fine if you put the positive and you get the negative. Your interpretation is that's the payment you're going to get. Okay. Any more questions about that one? follow exactly the steps that are there and you should get the answer. Oh, maybe I have to put FV. Isn't you have to put 0 into FV. It's another typo there. Okay, keep at it. I'm going to continue. Just try it again. All right, so what I'm going to take a break here to talk about the difference between periods of interest or periods of growth and payments in the timeline. So here's the basic timeline, and what I've done is I've marked period or end of period 18 and end of period 55. And I asked you the question, how many periods of interest or growth occur between the 18th and the 55th period? End of the 18th and the end of the 55th. So how would you figure that out? So I suggest your instinct would be 55 minus 18, right? Just to verify, this is a terrible drawing, but here's your hand, 5 fingers, and in between there are intervals between the fingers. So you can think of the fingers as the tick marks and the in between as the intervals. And if you numbered your fingers 1, 2, 3, 4, and 5, they would be synonymous to 18, 19, up to 55. Now, how many intervals or how many spaces are there between the fingers? If you subtract 5 by 1, you get 4, which is correct. There's 4 intervals. So that could apply here too. 55, the last one, minus the first one, 18, would tell you how many intervals there are. So when I ask you, what are the number of intervals between end of period 1 and end of period 5, you just take 5 minus 1. In that same spirit, you take the number of, to get the number of intervals, you take the end of the last minus the end of the first. So 55 minus 18 is 37. So if you can't see it clearly, you could make the calculation to get your answer. Okay? Owie, you're going to have to practice and let me know if you still have trouble, okay? I'll finish this and I'll go back if you still haven't gotten it. And this also applies if you want to go from the beginning of the last period. So that would be 54. That would be at the beginning, wouldn't it? So if this was, 17, this was 54, this would correspond to the same period. The beginning of the 55th period is 54. The beginning of the 18th period is 17. You also do the same thing. You can just subtract them and you'd get 37. But what if I wanted the number of payments? So not intervals, but payments between 18 and 55. Again, looking at your fingers, and I number them. and I want to know how many fingers there are between the first and the last, I can't do 5 minus 1, that'll give me 4. I have to add one of the fingers back. So when you're asked for the number of payments, you have to use this formula. You have to take the end of the last period, 55, minus the end of the first period, 18, and add 1 back, and that will be 38 payments in between there, inclusive. Okay, so those are the two different types of questions you'd be asked when you have a timeline that you can't visualize completely, but you need to know how many periods in between two place marks there are, or how many payments. Okay, so we have the general formula. I'll just put it like this, but it also applies as long as you go from end to end or beginning to beginning. Now, I'm not going to talk about this until a later point. This is going to come up again, but you need to remember this trick. And that takes us to interest rate conversions. I don't want to do interest rate conversions yet. I want to review the exercises I gave you. Then I'll give you some more exercises, and then we'll start interest rate conversions probably tomorrow, because we have an hour and a half still to do today. We'll have enough time to cover the exercises. So let's just look back here. What is the problem with OB? Do you get this result? So this result, you hit store 1, you clear your screen, and you start entering these values in. I'll do it one more time, and then I'll leave it for you to practice. So to get through the first step, you hit 30, N, 12, interest, 0 in PV, 3,000 negative into payment, and you ask to compute, sorry, not that. I ask to compute FV. Then I store 1, and clear my screen. Then I'm ready for the second part. 20 into N, 12 into interest, recall 1, put that into PV, and I suggested to change the sign, and then 0 into FV and ask for the payment, and that's the answer. So practice that after class. I'm going to continue with the new material. Not new, but review material. All right, let's see. Let's look at the exercises. Did you try these? Do you have any questions about these? I gave you an idea of how much weight I would put on each of these problems. So I gave you these questions and the solutions. Do you want me to do any of these, or are you all right with doing these yourselves? Let me project the answers. Yeah, so this one's okay then, Kevin? You guys are fine with this on your own? Are there any problems on this review? In this problem, the mortgage is a loan, right? So that is the present value amount received, and you want to know what the payment is. So it's just an annuity. And then these two are perpetuities, using the idea of dividends for stock. So it's using the concept that the value of an asset is the present value of future cash flows. We use the dividend amount to be received, projected to be received, and those are just perpetuities because we assume the corporation can exist forever, so we use perpetuities to solve. So no questions about this? Okay, so you guys are good with this? So what I'm going to do is I'm going to send you more problems like this but more complexity. So similar kinds of problems but with greater complexity and realism, really. So I'm going to pull up the annuities review, which is here. And let's try this. I didn't give you the solutions because I wanted to work on them, but I can send those to you too. So for this problem, $1,000 for 5 years starting 4 years from today. So I'm going to call this a deferred annuity. I gotta redo this. I'm going to make them smaller and then just increase. Magnify the view. So 5 years of $1,000 starting 4 years from today. So it means that the amounts will begin here and continue for 5 years. So this is the timeline. So if you can draw it, it helps to visualize, because you want to match it to a formula. Is that 5? Okay, I'm going to stop. So that's 5. 1, 2, 3, 4, 5 brings us to year 8. So I don't need this extra stuff here. So I have the first cash flow is in the starting in the 4th year. right? So 4 years from today, 1, 2, 3, 4 is the end of the fourth. But to apply my formula, the formula fits here, one period before the first payment, and it is an annuity. It's an annuity of $1,000 at a rate of 8%. So it's the perpetuity with the adjustment factor, because I cut off those later amounts for 5 years. So that's that part. I can punch that into my calculator to get an answer. And then the next part is to find the value at time 0. That would be the the present value of this annuity starting in year 4, but discounted for 3 periods to get me back to today. So I need the value at time 0, so this needs to be discounted 3 periods. So that is my approach. Those are my formula. That's all I have to write on my test. Now, what do I write in my calculator? So I'm going to put in my calc, and then I will say that the payment is $1,000 to be received. So it's a positive. And I don't need to use FV. I have to compute the PV and get an answer. So I'll put the answer here. For that. And if you enter it like that, the answer comes as a negative. You just have to know that I'm going to write 399271. I'm going to write out the rest of the decimals too, to remind you not to round intermediate calculations. You should hold all those decimal places. You could actually leave the negative in your calculator and then discount it. It'll become a positive. So this will be what I need to store. I'm going to store that in 1. And you can just leave it as a negative. So you hit store 1, so it's in there with all the decimal places. And now I want to discount it. Now you could just mathematically divide by 1.08 to the power 3, but let's practice with our keys. Again, I'm going to enter now 3 into, and because 3 intervals have to be discounted. Interest is 8. The PV is what I want. And there are no payments. But I have to recall. I'm going to erase this out of the way. I need to recall what I stored as the future value, because this is not only the present value of 3, but it's the future value of 3. And if it's any clearer, I can put that here. Or I can leave it as PV. They're the same thing. But this might be more familiar because that's the formula that we learned, right? And then you get your answer. So do you get this answer? circle my final answer. So at the end, you can round to decimal places. Anybody else get it? Okay, so you guys can get back to me on that one. Try the second one. I'll give you 10 minutes. And I want to see it as annuities. Remember, I don't want to see you use the net present value formula. I want you to use annuities. So try this one. I'll give you 10 minutes. That's maybe too much, but 10 minutes. Okay, I'm back. Angel got the wrong number. Okay. So let's work on the second one now. I have my neighbors moving furniture. I think they're the noisiest neighbors I've ever had. I live in a condo. They're upstairs. But you know, it's okay. It's all right. Maybe I'll be noisy one day. I think I am noisy, actually, for the people beneath. All right, let's get going on this. Starting 1 year from now, we will receive $2,000 for each of the next 3 years and $3,000 for an additional 2 years. So let me draw that. Again, I asked you to use annuities. This is for practice. So I'm going to, well, actually, I want to make that in a different color. That should be in, what did I use? Black. One minute, sorry. Okay. Oh, it looks like the screen isn't updating. Hold on. I have to reconnect. Okay, let me reconnect this thing. It broke. Connection broke. With my iPad, because I guess it idled too long. I'm back here. All right, so I am going to receive for each of the next 3 years. Okay, so 0, 1, 2, 3, and then 3,000 for 2 more. I could have made this bigger, couldn't I? It's okay. 4, 5, okay. I can't erase my line. So it's 3,000, 2,000 for 3 years, and then 3 for 2. Always moving furniture. All right, so I have an annuity here and I have annuity here, but this annuity starts immediately, well, actually at 1 year. So this is the regular annuity formula that I'm going to apply. And then there's this one over here. That's an annuity for 2 years. They're both at the same 10% rate. So this one will be PV3. So I'll call this part A and I'll call this part B, right? And then the last step is, well, there's 2 more steps. I would have to discount this one back to time 0 and then sum the 2. So let's start at the end, and I'm going to store my results. So this is going to be $3,000 at 10% for 2 years. And putting that into the calculator, not this one. So 2 years, 10%, payments are $3,000. And I put a 0 in FE and ask for PV, and then store that. I can store that as a negative, I guess. So store 1. And I keep all the decimal places. So that's, actually, let me see that number again. 5206.61. So this is the store 1. Store as negative. It's fine. And then I'm just going to check my connection. Things look good. And what I have to do with that is, and then change the color, discount that back here. This would be PV0B equals PV, or let's call it FV. FV3B at 10% for 3 years. And I want to say this is the same as FV3B, right? Because it's the future and the past. Present value, future for cash flows, or future value of the past. So this will be recall 1 divided by 1.13. And what do you get there? I get $3,53337 . So that's what I get. And I keep all the decimal places and I store that in 2. I can store it in 1 as well. I'll store it in 2. So just be careful, pay attention to your signs. The sign is positive now, so I'm going to store it as a positive. That'll be good for when I sum these things together. So the last thing I have to do before I sum them is figure out this amount up here. And so I'm going to clean this up a bit and call it PV0A is 2,000 divided by 1.1. This is the annuity for 3 periods. And that's it. So let's put that in the calculator. N is 3, interest is 10, PV is what I want, payment is 2,000, 0 is FE, compute PV. And store all those values. So we're going to store this in 3. And then we're going to sum recall 2 plus recall 3. Make it up positive, okay? Store as a positive. So given the way that we wrote it, we have to change the sign. So you're going to have to put the sign as a positive. Okay, so let's do this one in the calculator. So I'm going to let's do the whole thing. So I had, from the beginning, I put in 3,000, for 2 years at 10%, I put in $3,000 and 0 and FV, and I compute, what just happened? I compute PV. So that's the first amount, and I stored it as a negative, store 1. Then I used the basic time value of money concept for 3 years at 10%. I'm going to recall this and put it into the future value with no payments and compute PV. So that's the second number. This one I store in 2. So that's part B. Part A is that part B? No, I have a different number. Let's do that again. It's 2 years and I have to go 3 years. Let me do that again. One more time. Is that the right number? 5206. Okay, so that's the right number. And I store that in 1. And then I have to do 3 years at 10%. I want to figure out PV. There are no payments. I recall 1 and put it into FV, and I compute PV. So that's not the same answer, is it? 391180. Did I make a mistake? Do you guys get that? I got it wrong. Okay, so 391180. Obi, you have to do it like this because I'm trying to get you to practice. Okay? This is what you have to do. You have to practice. So this one was wrong. 3 years. Maybe I had something. I'm checking my numbers. Oh wait, so I get this number 3911804. That's the correct one. And then above, so I'm going to store that in 2. And then the part A will be 3 periods So everybody's okay so far? You got all these numbers? So I store that in 2, and then for the last part A, it's going to be 3 years at 10% of $2,000, and I want the present value of that amount. Is that the right number? Same number. And I'm going to store that in 3. And then all I have to do, I want to store the positive though, so I'm going to change that, store 3. So what I have now is recall 2 and recall 3 that I have to sum. So recall 2 plus recall 3 is my answer. So that's it. So to recap, we started at the back end, and I took these 2 and I made an annuity of those 2. The value is 1 period before the first payment. Then I discounted to time 0. Once I have that, I add that to this amount here. So the final step is to sum. And that gives the answer that we're looking for. Questions? Practice makes perfect. Perfect practice makes more perfect. Not making mistakes as you practice. I mean, you're going to make mistakes, but you need to continue studying to resolve those mistakes, those errors. Ready for the next one? All right, next page. So this next one is the annuity due, and above I review the different ways you can answer this one. So starting today, we will receive $2,000 for each of the next 5 years and $3,000 for an additional 3 years. Goodness. So today, for each of the next 5 years, Now, for 5 payments, it's only 4 years have transpired because the first one is today. And then 3,000 for 2 more years. At 10%. So there's different ways to do this first part. Again, I'm going to divide it up into parts. This first part is an annuity due if you do it up to here. With 5 payments. And this one is going to bring us 1 period before, so PV4, and this is part B. And we're going to have to then drag that back by discounting. Okay, so this is a regular annuity with 2 periods or 2 payments. So let's do it like we did last time. Did I make a mistake? Oh, 3 years, thank you. Thank you. All right. So I'm just looking at my color scheme. Okay, so I'm going to stick with black. All right, so this is going to be a 3-year regular annuity. 10%. So you have to write this out for your test. And that's done. So let's continue the same way as we did before. This would be on our calculator 3003, right? So it's 3 periods, a 10% of $3,000, 0 into FV, we ask for PV. So 7460555973. Store 1. And I'm going to make a note, always make a note. I stored it as a negative. Now, I'm going to discount that 4 periods to get that answer. So remember, I can call this the future value of B and take this back 4 periods to get an answer. And this would give me, using recall 1, what number? So store 1, and then for how many periods? I said 4 periods. Yep. Okay, so remember, even though we start here, we have the formula applies 1 period before, and then that leaves us 4 periods to discount. So it's 4 periods to discount at 10%. There are no payments, but we're going to recall this amount and put it into FE and compute the PV. So 509,566. Store 2. Did I do that correctly? Store is positive. Just again, 509,566. And you do not round intermediate calculations. That's why we're using the storage. Don't round those decimals. Okay, so we have that in store 2. Now we have to carry this out. So how are we going to do this one? This is an annuity due, so I'm going to use the formula of putting 2,000 and then the annuity for 4. That is the annuity due formula. To get it out of my calculator, I can do this with a annuity of 4 plus 2,000, but I'm going to use the begin mode to do this, okay? So let me circle what I've done so far. I got this value, and then I got this value, and now I'm doing part A. So I'm going to use begin mode for this part A. I am going to set my calculator to begin. Second, begin, second, set. It's ready now for me to calculate 2,000 for 5 payments. Okay, so if you put it in your calculator in begin mode, you treat it like it's a regular annuity, and the calculator will make the adjustment. The adjustment that it makes, as we discussed last class, is that it will, because you put it in begin mode, it will find the value here and then adjust it 1 period. Okay, so we're ready for 2,000 for 5 periods. So it's 5 payments, 10% of 2,000, and I want the present value of that. So that's the amount. 839.73. I'm going to change it to a positive and store it in 3. 833973. That's a 3. Anyone have a different answer? So I'm going to store that in 3 as a positive. And my final answer is to add A and B, which is just recall 3 plus recall 2. Or 2 plus 3. And then you'll get this answer. Questions? Okay, no questions? Everybody's fine? You're gonna practice that? It's 11:45. I'm thinking to just stop right here, but I'm going to send you another couple of documents you can work on tonight for practice, okay? And we'll talk about them tomorrow, but really I want to start interest rate conversions tomorrow. But I will send those documents for you to get started studying or practicing more intensely. Anyone have any questions? So you can review this video, you can ask me questions. If you're still getting stuck, you can tell me tomorrow or you can email me tonight. Okay, so I'm going to say bye for now. Have a good night, have a good afternoon. Have a good day. I'm going to I'll ask you to check your email. I'm going to send you some more documents to practice, okay? See you tomorrow. Bye for now.